Okay, problem number 43 from chapter 5. Here we have two blocks, each of the mass m, which is equal to 3.5 kilogram, hang from the ceiling of an elevator as in figure 5.43. Now in part A, if the elevator moves with an upward acceleration of the magnitude 1.6 meter per second squared, then you have to find tension T1 and T2 in the upper and the lower strings. In part B, if the string can withstand a maximum tension of 85 Newton, which is a T1, what is the maximum acceleration can the elevator have before string breaks? Okay, so let's draw our mass on the elevator. So here we have two masses. This is our M1. Since both of them are same, we just keep it M. Here we have M. Okay. Then here we have the string. So it's attached to the elevator. This is our tension 1. Here we have tension 2, and elevator is moving upwards with an acceleration. Correct? Now the acceleration here is equal to 1.6. Then the mass is equal 3.5 kilogram. Then, okay, so let's first of all solve the part A. Now, let's draw free body diagram for two separate masses. So this one we'll call it 1, which is upper mass, upper box, and then 2 is the lower box. Okay, for the first one, what we have? We have mass, right? We have here tension 1. Okay, then what we have? Then we have the weight of the upper mass, which is, let's say, Fg. Okay, then what else we have? We have the tension that is coming from lower box. Okay, now let's draw a free body diagram for the second one, for the second box. For the second box, this is mass. We have a tension 2, and then we have the weight of the box. Now you have to keep in mind that this tension 2 is the same in magnitude but opposite in direction. Okay, so first of all, let's find what is equal our weight here for each boxes. So the mass of the box is 3.5. Now multiply to the 9.8. So your Fg should be equal to 3.5 multiply 9.8, which should give you 34.3 newtons. Okay, now okay, so let's find tension for separate boxes. Now when you're trying to find the tension of separate boxes, try to choose a box which has minimum forces on it. So as you can see here, in the second box, which is lower box, we have only 2 forces, but in box 1, on the upper one, we have 3 forces. So to make our life easy, we will just choose the second box. We know that two boxes, box upper and lower, both of them are moving with the acceleration upwards. Now we're defining that upwards is a positive. Okay, so then using the Newton's second law, we can say that sum of the forces is equal to ma. Now we have to keep in mind that it's only moving in the positive y direction. Okay, so that means sum of the forces in the box 2, what we have? We have tension 2 minus Fg, which is equal to ma. Now from here you can find T2, which is ma plus fg. Now our mass is equal 3.5, the acceleration is equal 1.6, plus our fg was equal 34.3. Now if you do calculation, then 3.5 multiplied 1.6, then plus 34.3, then you will get that your tension 2 is equal 39.9 newtons. Okay, now so we found tension 2. What about tension 1? Okay, now let's write down equation for the tension 1. So if it's moving with acceleration upwards, then again we use Newton's second law, which means sum of the forces is equal ma, right? So in this case, the sum of the forces in the upper box, what we have tension 1 positive because pointing upwards, minus fg, which is the weight of the box, then minus tension 2, that is equal to ma. Okay, you have to keep in mind that this m is for the upper one. Okay, so then tension 1 is equal fg plus tension 2 plus ma. Okay, so then your tension 1 becomes fg was equal 34.3 plus tension 2 was 39.9 plus mass is equal 3.5 multiplied acceleration 1.6. Now let's add them all. 34.3 plus 39.9 plus 3.5 multiplied 1.6. So you should get that your tension 1 is equal 79.8. Okay, so we found that our tension 2 was 39.9 and our tension 2 was equal to 79.8 newtons. Now in the part B, it says that if tension 1 is equal 85 newtons, then maximum acceleration can elevator have before string breaks. So we have to find what might be the maximum acceleration before string breaks. Okay, so in this case we can do like this. Okay, so instead of considering two boxes as separate, we can consider also as a one box. So say that we have this box, that box. Okay, so that means we will have a tension here, tension 1. So we have to find tension 1, and both of them are moving with an acceleration upwards, right? So what about this fg? So fg here, which means both masses are equal, so we can say that 2m multiplied to the g. Okay, so let's do calculation then. 2 multiplied mass is 3.5 and multiplied 9.8, so we get 68.6 newtons. This is our weight for the two boxes, right? Now then, using the Newton's second law, we can say that sum of the forces is equal ma. Now you have to keep in mind that this m is actually the total mass, so I define it as a capital M. Okay, so in this case you can say that here sum of the forces is equal to the tension 1 minus the weight of the whole boxes is equal to total mass of two boxes multiplied to the acceleration. So here we have to find the acceleration. So the acceleration is equal tension 1 minus Fg, which is the Fg of the two boxes, divided by total mass, which is m plus m. Okay, so in this case our tension, if it's equal to 85 newtons minus Fg, what we got 68.6, then divided total mass was 2 times 3.5. Now let's do a calculation. 85 minus 68.6 divided 2 times 3.5, so we get that our maximum acceleration is equal to 2.34 meter per second square. So above this acceleration, the string will break. This is what we have to find.